So like I promised you guys, we're going to talk about the cycle of time, right? You guys saw in the book how the moon changes and it has different phases, but the book made it seem like the moon got smaller and smaller and bigger, right? And so with that said, I'm going to start from the beginning and then bring you guys to what the book was talking about. And so when we look at the sun, you guys know where the sun rises? Or do you think it just stays in the sky all night? You think the sun stays in the sky all night, or do you think it gets dark at a certain time? It gets dark. And every morning the sun rises from one section of our hemisphere and eventually comes around and sets. You guys know what section of the hemisphere the sun rises in?
I know that the sun stays in one place. It looks like
we're spinning. You think the earth is spinning? Okay. And the sun doesn't move. Good. What about you? You're going to say what she was saying? Bummer. I'm sorry. Hey, that means great minds think alike, right? Go ahead. The east or the west? That is a great answer. So with all of your guys' answers combined, let's just narrow in on the direction itself. And the sun rises in the east. So if you guys wake up and you have sun shining through your bedroom window, guess what? Your bedroom is actually facing the east. And as the sun comes up from the east and starts coming around, where do you think it sets at? The west. Good. So now I have a tricky question for you. Where does the moon rise? Close. Close. The east. And where do you think the moon sets? In the west. The moon always rises and the sun always rises in the east, and the moon and the sun always set in the west. There is no other way for it to happen, okay? And when the sun rises, we have what is called daylight. Some people like to call it day, but day is actually just a cycle of time, okay? So when we look at our day, how many hours are in our day? Close. 24. We have 24 hours of the day. Now, there's some days where we have 12 hours of daylight, right? But we have 24 hours in our day. So if we have 24 hours in our day, how many minutes are in an hour? Who said 60? Hey, look at you. And how many seconds are in a minute? 60. So this means there are 86,400 seconds in a 24-hour day. Wow, is right. And this means that there is 1,440 minutes in a 24-hour day. And of course, there's 24 hours, right? So most of the people who live in the United States, which is the northern hemisphere, we live in the northern hemisphere. We have the northern and we have the southern hemisphere. But where we live at, we live in the northern hemisphere, okay? And so most of us who live in the United States, we follow a 24-hour day. Did you guys know that? Well, we're just going to focus on what we do today because it makes it a little bit easier. If we start wondering what everyone else does and what calendar they follow and what time they follow and all of that, we're going to be here a very, very, very long time. But I highly recommend that you go home and you ask your parents to help you to learn about some of those things, because I think you're actually going to enjoy it and feel very enthused and enlightened, and your brain will be full of way too much information, but it will be really cool to learn those things. So that 24-hour day includes daylight and darkness, just like we talked about, right? And daylight includes the shining of the sun, and the darkness, most nights, include the moon. So in the United States, most of us here follow something. This is how we get to work and know what day it is. It's called the solar calendar. With us observing the most up-to-date solar calendar, it's called the Gregorian calendar, okay? And before we had the Gregorian, we had the Julian, and before the Julian, we had the Roman, and so forth. So it keeps going. So go home and study calendars too, because that will be very exciting for you. But I'm not going to bore you guys with calendars today, because like I said, we will be here a very long time. But what I am going to explain to you is that we have the solar calendar, we have the lunar calendar, and we have the lunisolar calendar, okay? And each of these calendars focus on a particular light that comes from the sky. So if you guys were thinking about the lights that come from the sky, what would you think that they would be? The moon, the stars. Is there another light that's in the sky? The sun. Good. So the sun leads what is called the solar calendar. And that's the calendar that most people in the United States follow. The Gregorian calendar is a solar calendar. And the moon leads the lunar calendar. But this is really cool. The sun and the moon lead the lunisolar calendar. So I bored you guys with all of that information to be able to share with you and to help you guys to be aware that without those two greater lights, which is the sun and the moon, those are the two greater lights of the sky, we wouldn't actually know what day it was, which week we were in what month it was. We wouldn't even know what season it was. Did you guys know that? Without the sun and the moon, we wouldn't know that. So when you guys think about being able to know what time it is, what are some of the reasons that people need to know what time it is? To get places on time? Where would they have to go to be on time? A party? Make it to the store on time? Why else does someone need to know to be on time? You guys want to answer back in the back? They have to make it the dance class? Then why do they need just to know, right? Just to know what time it is, right?
When they have people, they don't know where they go.
When we have someone spend the night, we need to know what time they need to go or go to bed even, right? Oh, they have a doctor's appointment or an appointment to wake up and go to sleep. Bedtime, meals. Yeah, some people are on a very strict schedule, right? So before we had clocks to tell us what time it was, how do you think people knew what time it was during the day and at night?
Also, I really don't like the smell of sometimes I don't.
Cool. So he uses his hand and he focuses on something about his fingers to be able to tell what time it is. I saw a hand over here before back there. So we watch the sun, and then as it's rising, we kind of know, and going from east to west, we kind of figure out what time it is that way. Okay. Calendars. Yeah, they had calendars before they had clocks. You're right. The sun. Yeah. So I am going to share with you. Yeah, go ahead. The moon. That's another great way. So way back in the time when I was born, no, I'm just playing. I'm just playing. There was clocks back then. Okay. The way back when there was a thing called sundials. Okay. Or something really cool called the Stonehenge. Have you guys heard of the Stonehenge? Yeah. And
How long ago?
oh, I would have to look, but I mean, some people still use sundials today, but most of us in the United States don't. There's a way to be able to tell time called solstices and equinoxes. They had shadow clocks, they had Chinese incense clocks, and many other really cool clocks. I know I'm throwing out all these clocks to you guys. You're like, I've got to go home and research this too, right? But the greatest clock of all, you guys, comes from the sky. Would you believe that? Because without what is in the sky, we would have never decided to make our watches, the clocks on the walls, the clocks on our computers, and stuff like that. And we can actually still tell time, just like you were saying, your dad does the finger thing to see what time it is. We can still tell time from the clocks in the sky still to this day. That has not changed.
Actually, when it's more like over here.
Yeah, you can just focus on morning, evening, and nighttime, right? From the sky. So we're actually going to learn about 2 simple ways to tell time today. And when you guys get home, I want you guys to practice on fine-tuning this, because you never know, you may need it, or it's just a lot of fun.
Hello, today I'm going to be showing you a super simple technique that you can use out in the wilderness to determine how long you have left of daylight, how long before sunset that is. And all you need is your fingers. So first off, unless you've had a mad session, hangover 3 style, I'm going to assume you know whether it's morning or afternoon. This technique only works in the afternoon. So all you need to do is hold your hand up to the sky, you place the bottom of your hand where the horizon is, and you layer the fingers up until you get to the sun. Each finger is 15 minutes.
So I want to share with you guys really quick that the horizon is where the land meets the sky, okay? Where the land, so here's the land, and then the rest is blue or gray or purple or orange or whatever color you're seeing in the sky at the moment. So where the land meets the sky is the horizon, okay?
So if there's 3 fingers between the horizon and the sun, that means there's 45 minutes of daylight left. If you've got 8 fingers between the horizon and the sun, that means there's 2 hours of daylight left. Something important to note is that if you're in a mountainous region, you should place the bottom of your hand where you estimate the horizon is, where you estimate sea level is. Sure, you can use it to the top of the mountain, and that will show you how long you have left until there's severely diminished light, but it won't show you the time until sunset. So for example, where I am now, I put my hand to the horizon. There's about 3 fingers between the horizon and the sun right now, which means I've got 45 minutes of daylight left.
2 minutes per
This can be
finger.
crucial information if you're out in the wilderness and want to know how long you've got left to set up camp or build a fire before the sun goes down. This technique works pretty much all over the world, apart from really far north, really far south, where the sun never sets, and you're 3 fingers away. It doesn't mean you're 45 minutes away from sunset, because that sun stays up for 3 months. Pretty much the rest of the world, apart from the Arctic Circle and the Antarctic, this works very accurately. I hope you found this tip interesting, and you never know, it could save your life one day. Thanks for watching. Make sure you're subscribed for more videos like this.
We are going to go outside later and we're going to practice that, but each finger is approximately 15 minutes, which your guys' fingers are a little bit smaller than mine, so maybe add like 3 more minutes, okay? But you're looking at the 15-minute time frame. So you can literally stack this on top of each other until you reach. But like he said, it only really works in the afternoon. So how would we know that it's afternoon? But if we don't have a clock to know if it's PM or AM, what's another way? Because we're focusing on the clock in the sky, right? So what's another way we would know? Yeah. It would be more towards the west, right? And we know what time it is that we're hitting afternoon because the sun has already been directly on top of us. That's usually around noon when the sun is directly on top above us. Yes.
What if we don't have a compass and you're still not sure which way to go?
Well, I guess it would always start off with what time of day you possibly may have gotten up in the morning. Now, if you didn't wake up in the morning and you got up in the afternoon, you wouldn't really be able to tell, right? So that's a good question. But usually if you're in need of knowing what time it is in the sky, you're actually going to probably rise when the sun rises and go to sleep when the sun goes to sleep because you don't have any other light to go by. And so when you rise, you're going to know that that sun is shining in on you, which means that you're in the east. And when you see the sun finally above you, you're going to be like, oh, it's starting to head towards the west. Okay. Does that answer your question a little bit? So now we're going to watch a video about how to tell time at night. Yeah. Because there's no sun at night, right? So let's try to figure out what time it is at night.
Did you know that you can use the stars to tell the time? Using the North Star, Polaris, the Big Dipper, and some simple math, you can get a rough idea of what time it is. Finding the Big Dipper is pretty easy. It is in the northern sky and looks like a spoon. Once you find it, drawing an imaginary line between the two stars at the end of the Big Dipper will help you find Polaris, which is also in the tail of the Little Dipper. The imaginary line between the Big Dipper and Polaris will serve as the hour hand for a 24-hour counterclockwise clock you'll imagine to tell the time. In this example, the hour hand is at 17. To find the time, take 17 and subtract 2 times the number of months since March 6th. If it's daylight saving time, add 1 to your final answer. Finally, if your answer is negative, subtract it from 24 so you have the time in the 24-hour format.
I'm going to show you guys something pretty cool here. And this is actually going to be able to help you guys figure it out. If you guys actually flip your page over, you will see what he was talking about. Do you see the Ursa Minor right in the middle of your page? How we use that particular constellation to be able to understand what time it is. And so when you can spot the certain constellations on your sheet, not only do those constellations help you to tell what time it is, but it also helps you to know what the season is, which we're going to talk about later. But you guys got to take those home with you so you guys can practice and look up at the sky and find the different patterns of the stars up in the sky. It's going to be a lot of fun, trust me. We are going to watch a video that kind of what she had mentioned about seeing the, like using the paper plate method to know what time it is.
Hi, I'm Allison Young, and this is how to tell time based on stars. When telling the time, we use a few factors to represent time elapsing. There is a reference point and a connected hour hand which spins around this center as the time goes on. Of course, these numbers are a visual representation of the hours passing. In the sky, the center is the North Star, also known as Polaris, because it is located above the poles in the center of the Earth, hence the term Polaris. To find it, locate the constellation the Little Dipper, which looks like this. It is this star located at the end of the handle. The hour hand is created by the constellation the Big Dipper. To make the hour hand, just draw an imaginary line between these two outer stars and Polaris. But to make things easier, here is a visual reference for the hour hand. Notice how, on both clocks, as time goes on, these hour hands spin around the center. The only difference is that the sky clock, the stars rotate counterclockwise because the stars rise from the east and set in the west, like the sun. Using this, you can find the raw time. So let's say our raw time is 5 o'clock. Keep in mind, this is only an estimate, and it is not.
Like she was saying in the video, that our clocks go like this, right? Well, they go like this, right? But the clock in the sky goes like this. It goes the opposite direction. So if you guys keep watching, you'll understand how to be able to figure it out. And then I'll make sure I send the instructions to you guys. And I have a really cool project for you guys to take home to be able to tell what time it is.
Not the final time. In the sky, a few other factors have to be accounted for. Each night, the stars shift a little west. Actually, they shift 2 minutes west each day, which adds up to the stars rising 2 hours earlier each month. So, to calculate the real time, you have to add 1 hour per month before March 7th or subtract 1 hour per month after March 7th. It is currently June, so you add 3 hours to our raw time, which is 5, so our new time is 8 o'clock. Now, because the star clock rotates every 24 hours instead of 12, like a normal clock, you have to double this time, so 2 times 8 is 16. Now you subtract this number from 24 to account for the whole counterclockwise situation, and our real time comes to be 8 o'clock.
So we subtract the number for 24 because there's how many hours in a day? 24.
The last step is to account for daylight savings time, and because it is daylight savings time, we add an hour. Our final time comes to be 9 o'clock. Even though this is a lot of calculations, after some practice, it becomes an easy way to tell time.
Okay, so I am going to is teach you guys so you guys can have it. So when you guys look at that sheet that I just passed out to you guys, it helps you to actually be able to figure out what time it is. And you can still calculate the raw time. It just is a little challenging, but raw time will be the closest to knowing exactly what time it is in real time, okay, with what our clocks say. It would be the closest, okay? So do you guys think you'll actually try to calculate what time it is at home by the sun and the moon and the stars? You think you guys will try? Maybe? Okay. If we can now know what time it is, we need to be able to tell what day it is and what week it is, right? So let's watch another video so we can have an understanding on how we can figure this out, okay?
Hi, my name is Emily Morgan, and I'm the author of Next Time You See the Moon from NSTA Kids. And I'd like to share a simple activity with you that can help you understand why the moon looks different at different times throughout the month. Why sometimes it looks like a banana, and other times it looks like half of a circle, and other times it looks like a big round ball. Well, to do this activity, you only need 4 simple things. You need a lamp with the shade removed, a white foam ball, a pencil, and a dark room. The darker the room, the better. Now in this model, the lamp is going to represent the sun, and of course the white foam ball is going to represent the moon, and your head is going to represent the earth. So let me show you how this works. We know that the moon orbits the earth. So in this model, I'm going to get the moon, the foam ball, to orbit the earth, my head. Notice that no matter where the moon is in its orbit, half of it is always lit up by the sun. But when the moon is in this position, I can't see any of the lighted side of the moon from Earth, my head. From this angle, you can see what I am seeing from Earth. We call this new moon. When it's new moon, we look up at the sky and we can't see the moon. It's there, but the side that's reflecting sunlight is away from us. Now, as I slowly make the moon orbit to my left, I can begin to see a tiny sliver of that lighted side. We call that a crescent moon. As the moon keeps orbiting, we can see more and more of that lighted side. We see half of the lighted half, which is a quarter moon. In this case, a first quarter moon. As we keep orbiting, we see almost the whole lighted side. We call that a gibbous moon. Then, when we can see the entire lighted half of the moon, that's a full moon. As the moon continues in its orbit, we begin to see less and less of that lighted side. We're back to a gibbous moon, but this time the light is on the opposite side. Then another quarter moon, last quarter moon to be exact. Another crescent. And finally back to new moon. And the cycle begins again. So why does the moon appear in different shapes throughout the month? Because of its orbit. The shape or phase of the moon depends on where it is in its orbit around Earth. It takes about a month for the moon to orbit the Earth. So when you look up at the moon today, know that you'll see that same phase again about a month from now. Thank you for watching, and I hope you give this activity a try. And I hope that you have a sense of wonder next time you see the moon.
Those are pretty cool. And it kind of answers some of those questions that we had when we read that book. Does the moon really grow smaller? Does it really grow bigger? Well, of course not. It's just showing how the light is reflecting off of the moon. Well, where does she say that light came from on the moon? The sun, right? So I have these pages for us, but we'll do these pages first. Okay, so when we are looking at the page that we have on our in front of us, and you're checking that all out, right? It explains to us the phases of the moon. And so, but we got the easy version for us to be able to fill in the blanks a little easier. So we'll go through it together. So when we start from right to left, and we start with that big yellow oranges thing right here, what do you think that is? The sun. So we're going to start with the big yellow thing, and we're going to look at that, and that's the sun, right? So then when you look at when we look at the next box on top above the sun, above those arrows here, as you guys can see on the screen, what do you think that answer is? Sunlight. So now we're going to look at the one in the middle here. If you look up at the screen, you see I circled it kind of ish. And we are going to look at this one, the one in the middle, and it starts with an N. What is it? New moon. So the new moon is also what's called the conjunction. And it's where we can't see the light reflecting on the moon, just like she was sharing with us in the video. And so when we are in conjunction, it is also viewed as the dark moon or the conjunction or the new moon. Okay. So now we're going to start with the one right above it. That's a tricky one because there's two that start with WC. So since this lighting of the moon is coming after the conjunction and it's the first visual crescent of the moon, what is it called? Waxing crescent. And this is a bad joke, but for those of you who have watched Karate Kid, wax on, wane off. Okay. You seen Karate Kid? Okay. Your mom's pretty cool. So we're waxing on, which means we're waxing into the full moon. And after the full moon, we're waning back into the dark moon or the conjunction again. So now we're going to go to the one in the middle at the top. And what would that one be called? First quarter. First quarter. Good. And so the first quarter is how we can tell that a whole week has gone by. Okay. We have now experienced a whole week since the conjunction. We now have 1 full week. We're going to go to the one in the middle on the left here. The one in the middle on the left. And what's that one called? It says FM, full moon. And so after our first quarter, now we're going to enter into the full moon. That means we've gone 2 weeks. Okay. So do the one at the bottom. And she already gave us the answer. It was last quarter. And so now we've gone 3 weeks. And when the moon is half lit on that side, on the left-hand side of the moon, we know that we are ending the monthly cycle of the moon. Okay. And then we're going to go to the top left. The first one was waning. And then the last one at the bottom is waxing, which I probably should have had you guys learn that after the waxing crescent. So I apologize for that. So I hope that helped you guys. But when you look at that, each one of those tells us what the week is. Okay. So the moon cycle is approximately 29 and a half days, you guys. 29 and a half days is the moon cycle. Therefore, if a person was going by the lunisolar calendar, if they knew how to count to 30 or 31, they would be able to know which day it was because they're counting from the first visual crescent, and they would know what the last day was because it's now a dark moon again. But if we count from the first visual crescent to the first visual crescent, it's not always going to add up to 30 or 31 days like the Gregorian calendar that we follow today. But there's something else pretty special about the moon, and it's just what I showed you guys. So when you guys look at that worksheet I gave you, so a 1 next to first quarter, a 2 next to full moon, a 3 next to last quarter, and a 4 next to the new moon. After reading each statement, decide whether it is true or false. Okay? And we're going to write the word true or false on the line provided. Okay, so when the part of the moon we see from the reflected sun is decreasing, remember, wax on, wane off. Is it waning? If it's decreasing, is it waning? True or false? Remember, wax on means that it's growing, it's increasing, and wane off means that it's decreasing. It's true. Okay. So number 2. Okay, so we didn't actually talk about nuclear fusion because it really had nothing to do with what we're talking about today. But phases of the moon are naturally produced light from nuclear fusion, and the answer is false. Okay, number 3, the full moon occurs when the moon is between the sun and the earth. False. Why is it false? It's a new moon. It's conjunction, right? And so if there's no light, it definitely can't be full because it needs the most amount of light to be a full moon, right? So number 4, the waxing gibbous phase occurs just before full moon. Waxing gibbous occurs right before full moon. So it's going to happen right around first quarter, right around that time. So a blue moon is a term for a second 2 full moons in a single month. 2 full moons in a single month, which we didn't talk about this. So some states back in November actually had the blue moon. Like people who lived over on the West Coast, the northern West Coast, they actually received the blue moon. So that means that at the beginning of November that they had a full moon, and at the end of November they had a full moon, and that's called a blue moon. You ever hear anyone say that once in a blue moon? You guys ever hear anybody say that? Yeah. And so it means it doesn't happen very often. So it's not a common thing for the blue moon to happen. Huh? Well, when the moon is red, that is about light reflection. and how close it is to the earth and how the light is reflecting off of the sky. And it's all about refraction and reflection. So I would research that one too. So now we can tell by the cycle of the moon what week we're in, right? So how can we tell what month we're in? So after the moon goes dark, like I said, if we can count to 30 or 31, we can know that our month is getting ready to end. And now this clearly isn't going to work based off of the modern day Gregorian calendar, but like I said, there was many calendars before that, right? But we can still use it. Let's say all the calendars got burned up. None of the clocks are functioning. We have no technology. We can use it to be able to figure out what time of year it is, what day it is, what week we're in, what month we're in. But all we have to do is know how to count to 31. So there's something pretty interesting. So now we know how to be able to know what day it is, because when the sun rises and sets, we've ended our day, right? We're now in darkness. So the cycle of time will start over when the sun rises again, right? And then we kind of know what week it is, because if we can count and look up at the sky and see the different phases of the moon, we know that the week is going by, right? And then we can kind of know what month it is because we know how to count. But there's another way to be able to know what month and season we're in, okay? Now, there's a thing called solstices and equinoxes. Have you guys heard that word before? Yeah. And depending on which hemisphere a person lives in, the solstices and equinoxes will mark that winter is getting ready to begin, spring is getting ready to begin. What's the next season? Summer. And what's last? Fall, right? So we are actually getting ready to encounter the winter solstice, because here in the northern hemisphere, we have the winter solstice, which in the southern hemisphere, what do you think they're getting ready to encounter? We're encountering winter, and their seasons are opposite, summer, right? So if a person lives in South Africa or something like that, they're getting ready to encounter the summer solstice. Yes. I would have to research that, because okay, so sometimes we think of summer as being hot, but just because we don't live in a hot environment, it could mean that in Antarctica during their summer months, it goes from 50 below to 32 below, which means that would be a warm time for us, right? But I would have to research that.
They do have summer, but it's just cold.
Yeah, it's still going to be cold. It's not going to be like our summers, right? It's going to be really cold. I think the only people that go there are like scientists and stuff, right? Did he? Mr. Beast went to Antarctica. I bet he was all geared up, right? You couldn't even see his face, could you? You could. We're going to have to look into that one too. Okay, so since we're getting ready to enter into the solstice, the winter solstice, you guys know what that means? It could. It does mark the season, but it's going to be the shortest day cycle of time with daylight of the year. Well, daylight savings time is a man-made thing. It doesn't really relate to the true seasons and calendars and clocks. When we're getting ready to encounter the winter solstice, that means that we're going to have the least amount of daylight, okay, which could approximately be only around 8 hours of daylight. And we're going to encounter this in less than 2 weeks. I think it's around like the 21st or something of this month of December. And you guys can watch and be like, man, what happened to all the light? There's no light. Like, it's like, I just woke up and now it's dark already. It's only 4 o'clock, right? And so when you guys encounter that, guess what happens after the shortest day of the year? The days start getting longer. And then as our days start getting longer, what do you think that leads us to? Because we did winter, right? Spring. So now we're going to have the spring equinox, okay? And the spring equinox is that other quarter. So each one happens in a quarter. So it usually happens around December is the winter one, and June would be the one in the summer, right? And then we have the spring equinox, which marks our spring. That's a lot of times people will say, okay, it's time for us to start sowing our gardens and planting our fields, because it's around that time that the frost is starting to dissipate and we're going to start entering into what now that we've entered the spring? Warmer weather, right? And we're going to enter into summer. Oh, sowing, planting seeds. It's just another word for planting seeds, sowing. And so if we're coming out of the spring equinox and we're going into summer, just like she said, what are we going to have then but the summer solstice? Okay. Now there's more technical names for this, but since we're in the Northern Hemisphere, I'm just going to keep it simple for our seasons. So the summer solstice usually happens around June 20th, June 21st. Okay. What do you think happens then? If in winter, we encounter the shortest amount of daylight, what do you think happens in June? It gets longer. And that's why you can be up at 9:30 at night and it's still daylight, okay? And it's going to be the longest day with daylight. That will be the longest day of daylight is the summer solstice. And then what do you think happens a few months later? Fall. And so we have the equinox that happens in the fall. And what does that mark? It marks time for us to start doing what? Harvesting, celebrating your birthday. What else do you think it tells us to do? So we're harvesting, we're getting our food prepared, getting ready for winter. We know it's getting cold. What happens in the fall? What happens? It gets cold. What else happens? The leaves start falling. And so we can start seeing that. Every 3 months, we're going to enter a new season, okay? So with the solstice and the equinoxes and the phases of the moon, we can actually watch this happen. Now, I want to teach you guys a trick. The sun and the moon rise and set in the same section every day. Now, there's going to be some days where you'll see the moon in the sky. Did you guys see the moon in the sky yesterday? Did you guys see that? That was super cool, wasn't it? And so that's telling us that we are coming out of our first quarter. Okay, so if we're coming out of our first quarter, what happens next on your paper? What's that big ball that we're going to see next week? The full moon, right? And so now we know that we have gone a week into our new month. And when the full moon comes, we know we've gone 14 days or so, give or take 15 days. And then it just keeps going one week after another, right? And so, but what's cool about this, you guys, if you guys start watching the sky, you'll see that the sun is setting in the southwest. Guess what? The moon sets in the southwest. And it's only going to set in the southwest for so many days. And it starts ticking across the sky like this. And before you know it, comes summer, you're going to see the moon setting in the northwest instead of the south. And then it's going to start going from northwest, and then it's going to just be right down the middle west. And then it's going to start ticking again, all the way back to where it's at today. And so if you watch where the sun sets, you'll be able to tell what season you're in too. So obviously, if it's setting in the southwest right now, that clearly tells us that we are entering our winter months. And as you watch it tick across the sky, you'll find yourself back into the summer months again, and then it will start ticking back. Tick tock, tick tock. And it does that. It has 6 different sections that it falls into every year. So it stays in each one, 6, 6, 6, 6, and then it goes back again. which equals 12. You guys have any questions about seasons, months, days, weeks on what I shared with you guys with regard to the calendar? No questions? Are your brains spinning? No? Okay.